Hello, calculus. It's Canfield. So today I'm reviewing for a quiz that we have tomorrow. So I'm going to go through this entire packet. I'm going to make sure that I spell everything out, and hopefully it's helpful for you. Hopefully you know a lot of it already, because you're supposed to, because this is supposed to be like, you know, the hey, did you learn everything? Not hey, did you learn it all at the last minute? But anyway, here we go. So it's find the value of c guaranteed by the mean value theorem if f of x is equal to root x minus 2x on 0 to 4. So 0 to 4 is an interval. It's not an x comma y coordinate. And if I'm trying to find the value of c guaranteed by the mean value theorem, that means that I first have to find the average rate of change on this interval. And so I want to know the average rate of change, and then I'm going to set that equal to the derivative and figure out when they're equal to each other. So the average rate, let's see, well, to do that, I'm going to do f of 4 minus f of 0 over 4 minus 0. It's just a slope formula, right? So if I plug in 4 to this, that's root 4 minus 2 times 4, which is 2 minus 8, so I got negative 6. And then I'll plug in 0, and root 0 minus 2 times 0 is 0. So I wind up getting negative 6 minus 0 over 4 minus 0. Hold on, I don't know if this is going to help. It just looks a little dark for me. Dim dark. Okay, so I got that, and I get negative 6 over 4, which is negative 3 over 2, negative 1.5, negative 1.5. So I'm trying to find out when the derivative is equal to this. So we got to take this derivative. Before I take the derivative, I'm going to remember that the square root of x is actually x to the 1/2. So that makes the derivative a little bit simpler. We know that then f prime is going to be 1/2 x to the negative 1/2 minus 2. And so I'm going to set that derivative equal to my negative 3/2. So negative 3 over 2 is equal to 1/2 x to the negative 1/2 minus 2. So I'm trying to solve this. I'm going to add the 2 to both sides. Let me switch to marker. It might make it a little bit more visible. But this one was more fun because he has a face. I can't tell if he's happy or like pretending to be happy, but he has fun hair. So anyway, I'm going to add the 2 to both sides. So that, remember, we said that's negative 1.5. So it's going to be positive 1/2 when we add them. So we get 1/2 is equal to 1/2 x to the negative 1/2. So I can cancel the 1/2s, like multiply both sides by 2. And I get 1 is equal to x to the negative 1/2. Now there's only one power in the world that we can take it to a power and get 1, like to any power. I mean, we can take anything to the 0 power and get 1, but 1 is our answer here. So x is equal to 1. And so the c value guaranteed, we could actually say c is equal to 1, and that's a little bit better, but if you said x is equal to 1, I'd be fine with that. So the idea is c is that special value that's the solution to that setup equation that we got there. All right, next one. Explain using Rolle's theorem why this has a max or min on negative 3 comma 2. So maxes and mins occur when f prime equals 0. Well, I could find the derivative of this, but that looks kind of spooky. Instead, Rolle's theorem tells us just to plug the 2 endpoints in. So what is f of 2 equal to, and what is f of negative 3 equal to? Well, think about this. If you plug in 2 here, it turns this first one into 0 times, it doesn't matter what this one is, because 0 times something is 0. So f of 2 is 0. And f of 3, same deal. We get 0 squared, but it's still 0. Okay, cool. The thing is, this is not enough to use Rolle's theorem. Rolle's theorem also requires me to state that it's continuous and differentiable, if it actually is. Maybe it's not. But if you remember this, if we FOIL all this out, this is going to be a polynomial. So we can say polynomial See, I need to think before I write. I'm like, polynomials such as f of x are always continuous and differentiable. That's a lot of words. I'm going to say f of x is a polynomial and thus continuous and differentiable. Since f of 2 equals f of 3, so since the two y values are the same, it doesn't matter what they are. By Rolle's theorem, f prime of c equals 0. The conclusion of Rolle's theorem is that the prime will equal 0 on that interval. So we could use brackets. I'm using parentheses. I'm pretty sure the AP exam accepts either one. So when in doubt, just use parentheses. Yep. Now, how many times? We don't know. We could say at least once. All right. Explain whether or not using theorems. So we can't just be like, no, it doesn't, or yeah, it does. Whether or not this has a horizontal tangent on -3, 1, justify your answer. So x squared plus 2x minus 3 over x plus 2. Okay. Well, x squared minus 2x plus 3. Well, it's a polynomial, so that's good. But so it's not a polynomial as a whole. And so we want to think, hey, are there any x values that are ever a problem for this? And it turns out, yeah, -2 is a problem for this. -2, oh, that's on my interval here from -3 to 1. Since -2 is a problem, in case you're missing it, if we were to plug in -2 for x, we would have a 0 divided by on the bottom. Like it'd be a 0 on the bottom. And so a number divided by 0 is bad news. It does not exist. And because of that, we can say f of x isn't continuous at x equals, that's just the at sign, at x equals -2, because f of -2 doesn't exist, so we cannot apply horizontal tangent would tell me Rolle's theorem, because horizontal tangent means the derivative is equal to 0. But it's fun. Like, I don't even have to test the endpoints or do anything like that, because it's just like, wait, I gotta check and make sure I'm allowed to do it first. All right. Number 4. So my chair creaks all the time. I'd be curious to hear from you guys, like, how audible is it in the videos, and is it obnoxious? And if it is, like, should I change it? Like, should I switch chairs? Should I sit somewhere else in the room so that I'm not sitting on my comfy chair? And oh, now it won't make noise. It's kind of noise. All right. Anyway, number 4, earthquake. Number 4. Given that f of x is continuous and differentiable, oh hey, it like gives us the necessary conditions. Okay, lots of stuff. Excuse me. Does there exist at least one real number c in the interval from -4 to 2 where f of c is equal to -3? Explain. So we're not asking about derivative stuff, so I know I don't need mean value theorem. Mean value theorem always talks about derivative. But I'm looking for a y value of -3. So let's see. Starts out high, goes down a little bit, goes down to -2, comes all the way back up to 6, goes down to 3, goes all the way up to 8, and then drops down to -4. Is the y value -3 in between any two of these that we see here? And yeah, we see, do you see the ant? Don't be cruel to animals. Just shoo them away with a kind breath of wind. Okay, so anyway, -3 is in between those two y values. So that means that there's some c value between 1 and 2 where we have the y value -3 when we plug that number in. I'm guaranteed it happens at least once here. It could happen over here too. It's just not clearly shown that it must happen. Because remember, the intermediate value theorem says that as long as it's continuous, we don't need differentiable for IVT. You say since f is continuous, and the way I like to say it is, since we're looking for -3, we say it's it's between f of 1 and f of 2, right? There's f of 1, then there's f of 2, and then the actual number we want is -3. Well, f of 1 is more than -3, and -3 is more than f of 2. So it's sandwiched in between the two. So since f is continuous and it's sandwiched by the intermediate value theorem, f of c is equal to -3 for some c on, I could say 1 to 2. So, which is also on -4 to 2, but I'm just going to say 2. And then like the paranoid part of me this is like one of those, can I go to the bathroom? May I go to the bathroom? It's one of those situations. I don't think this is super important. I think everyone's going to know what you mean. But little old paranoid Mr. Canfield wants to write that down. Okay, can you verify f prime equals 0 on -4 to 2? So, f prime equals 0. It's like a roll, and so that reminds me it's rolls. Well, rolls, we need f of a to equal f of b. We don't really care what they are, as long as the two endpoints equal each other and have the same y value. 6 and -4, oh, they don't have the same y value. And wah. But maybe we can do something similar that we did here. Maybe there's a smaller interval in here where we're going to have the same y values. So, let's see. Oh, I see I have a y value of 6 here and a y value of 6 here. That means that between -4 and -1, there's going to, Rolle's theorem applies. So, yes, I can. Yes. All right, part C, no, just kidding. It says explain. We have to make sure we use our mathematical arguments. So, f of x is continuous and differentiable. And f of -4 equals f of -1. So by Rolle, I missed that. Rolle's theorem, there we go. You got to roll the R. Rolle's theorem. F of c, nope, not f of c, f prime of c is equal to 0 for some c on -4, 2. Nope, not -4, 2. -4 to -1. And it is important for us to use the interval that we're actually showing here, because we're saying, look, f prime equals 0 has to happen here. It may happen over here, but I can't prove to you that it has to happen somewhere there. It has to happen somewhere here. It's not fair to say that this area is also possible. Although, with a little bit of clever thinking, I'm sure you could easily see, and I'm just going to say this just to be a little bit trolly. So I'm just going to use 6 again. So from 6 to Well, think about this. If we're at 8 here and we're at 4 here, don't we have to hit 6 somewhere between there? So I go from 6 to 6. That was my desk. The lock opened up. So 6 to 6. So then we could say there's some value in between 1 and 2 where y equals 6, and then we're going to be able to say between those two values. And so we could kind of troll our way there. Don't worry about that. That's just, again, me overthinking problems. All right, explain what the mean value theorem tells us about -3 to 0. All right, let's see, -3 to 0. Well, mean value theorem normally tells us that first we have to find the average rate of change. And we do that by doing f of b, which is f of 0, minus f of a, which is f of -3, over b minus a. So 0 minus -3. So f of 0 is 3, -3 is 5, over 0 minus -3 is 0 plus 3, it's 3. So then I get -2/3. Mean value theorem, by definition, says on -3, 0, f prime of c must f prime of c equals -2/3 at least once. So it'd be a little bit more formal, I should say, for some c. For some c on -3, 0, f prime of c equals -2/3 at least once. That's it. That's what mean value theorem tells us. All right. Wile Coyote orders a jet-powered anvil from Acme Corps with the intention of having flattened Roadrunner for dinner. He carries the anvil to the top of an 800-foot cliff and throws the anvil straight down at 40 feet per second. I think I said jet-powered because that's fast. I don't know. Write the position equation that represents the situation. So we're given the setup for it. So that's going to be -16t squared. Oh, I should have written s of t. S of t is equal to -16t squared. This is plus v naught t. If it's getting thrown down, that's minus 40t. And then plus our height of 800. All right. So find the velocity at t equals 2. So b, we'll need our velocity equation. Well, the velocity is just the derivative of position. It might be hard to see. That says s of t. So velocity is the derivative of position. So that's going to be what? -32. -32t minus 40. So if I want the velocity at t equals 2, I literally found the velocity, I'll plug it in. It's -64 minus 40, which is -104. Now, I'm talking velocity here, and I'm given units in this problem, so I need to use units. It's going -104 feet per second. Okay. Part C. It wants the acceleration at... Oh, I just accidentally forgot that I'm on camera and took out an ant. All right. Don't tell PETA. So... acceleration is just the derivative of velocity. So if I take the derivative of that, I'll get acceleration is -32. And then remember that acceleration, the units on that are just like feet per second, but it's feet per second per second. So we write feet per second squared. Find the average velocity on the interval from 1 to 3. Average velocity, slope formula. So that's going to be position at 3 minus position at 1 over 3 minus 1. And position at 3, so I just got to plug 3 into my position equation. Let's see, so it's negative 16 times 3 squared minus 40 times 3 plus 800. So let's see, that's 9. 16 times 9, I think is 144. 90 and 54, yeah. 144. 40 and 3 is 120 plus 800. So was that negative 264 plus 800. So that's going to be 536. Then we have 536 minus, and now I gotta find S of 1. S of 1's gonna be super hard, so I gotta plug in 1 for t. The hardest part apparently for me was writing 800 right then. Okay, so let's see, 800 minus 40 is 760, minus 16 is 744. 3 minus 1 is 2. Believe it or not, my brain right now is going to have an easier time dividing everything by 2 first. I don't know why. Don't ask. So 536 is 268 minus 744 is 372. Not much easier. All right. So let me do 372 minus 268. That's a 12. That's a 6. That comes down to a 2. The 2's cancel. No, they don't. It's a 3 there. Sorry. That's not a 2. 372, 268. So 2 turns into a 12. That turns into a 6. Okay. 3 minus 2 is 1. 6 minus 6 is 0. 12 minus 8 is 4. I got 104. So, so I gotta wait. I got negative 104 feet per second. So that's fun. When I made this problem, I chose an interval that happens to have the average accelerator or the average velocity that is the same as the velocity at this instant. So this actually is the c value. 2 is the c value on this interval. I doubt I did that on purpose, but it's possible. Part E. Assuming he misses the Roadrunner, as usual, find the time the anvil impacts the ground. Well, we just want to know then when position is 0. So I can say 0 and set it equal to my position equation. So if I do that, I'm going to divide everything by a negative 2 and get 8t squared plus 20t minus 400 divided by 4 more. So I know I could have divided by something bigger here. That was just, sometimes I know my brain's going to take a long time to think more about it. So I can divide by 4 here. All right, my brain's able to do that right now. So 2t squared plus 5t minus 100. So factoring this, slightly challenging. So I got to multiply to negative 200. I'm going to have a tough time if I don't get it in the first couple. Assuming it does factor at all. I mean, it's a physics problem. It could be something far uglier. Let's see. So if you're seeing it, that's awesome. I'm currently not seeing it, so I'm going to resort to the Pythagorean theorem. Wow, the quadratic formula, because I know the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I do that, negative 5 plus or minus square root, let's see, 25, that's going to be 800, so 825 when we add them all up, over 4. I don't think 825 is a perfect square root. It's a dead calculator. Are you also a dead calculator? Yeah, but not quite as dead. All right, well that might be why I was having a hard time factoring these. So you're not required to simplify these or anything like that. So now we can use our common sense though and say, hey, there are two numbers here, right? Negative 5 plus that and negative 5 minus that, then divided by 4. Well, we're dealing with positive time, right? So the time that it happens is going to be negative 5 plus the square root of 825 over 4. And for those of you that really want to simplify that square root of 825, I know that this is 25 times 4, then times 8, so 32, so 33 quarters, right? Because, yeah, okay. So I could rewrite this as 5 root 33, and that's only 3 times 11. That's its prime factorization, so. All right, so that's our time. All right, we only got 2 more parts to do. So part F says, oops, I was starting to write f of x. So F says, find the speed of the anvil when it hits the ground. Well, we know speed is the same thing as velocity, kind of. So negative 32, and I'll just plug in my time. And that's what, negative 5 plus root 825 over 4. So it's going to be the absolute value of that, and that's my speed. And that's going to be, oh, this should have been seconds over here. This should have been miles, feet per second. So whatever we get there, it's going to be a positive value, and we can use our calculator to get it. And then, when is the instantaneous velocity equal to the average velocity on 1,3? What theorem does that fulfill? That's just, since we actually already got it, which is really funny. It's when t equals 2, and that's considered our c value for the mean value theorem. Man, I'm really yawning today. All right, so we have one more problem to do on this. It's about Bobby. Bobby's car runs out of gas up a hill. Then Bobby passes out and doesn't touch the brake. The car rolls to a stop and then starts rolling backward. As it moves, its displacement dt in feet from the bottom of the hill at t seconds, since the car ran out of gas, is given by that formula. How far from the bottom of the hill was Bobby when he ran out of gas? So, all right, so how far from the bottom of the hill was Bobby when he ran out of gas? Well, so part A, literally, you plug in 0 for t, and you get 145, right? So 145, is this, there are no units. Therefore, we don't need to include units. So let's look at B. When he is moving up the hill. No, when is he moving up the hill? Down the hill? Okay, so let's find out. We're going to need velocity for that, right? So that's going to be the derivative of displacement, or the derivative of distance. So that's going to be 31 minus 2t. And so the important thing is, with velocity, when it's positive, we're going up. When it's negative, we're going down. So if we find out when it's going 0, that's kind of the key time. So hey, when does it equal 0? I'll add the 2t to both sides, and then I'll divide by 2, and I'll get t is equal to 15.5. So at 15.5 seconds velocity, velocity of 15.5 is 0. So that means he's rolling up for 15 seconds, and at 15 and a half seconds he stops, and then he starts rolling back down. So, so the way that we figure out when he's going uphill and when he's going downhill, I mean, based on this scenario, I think it makes sense that he's going to be moving up first, pause, and then move down. But I'm going to double check using a sine chart, because we didn't make such dramatic leaps like that in class. So our 0 of our velocity.
I'm back.
Hey. All right, let's see. So we had our t here. We had 15.5 here. So remember, 15.5 is going to make velocity 0. And I just wrote VT because, like, plugging numbers in here is not going to be super, like, I'm not going to want to write that there. You could have written it there, though, like we've done before. So I'll pick a number less than 15.5 over here. Literally any number less than 15.5. So I'm going to pick 0 because that's easy. And then I'm going to pick a lot, like 1,000 or something like that, right? If I plug in 0 to velocity, do I get a positive number or a negative number? I get a positive number, so that means velocity is positive here. If I plug in a huge number, that's going to be 31 minus 2 times a huge number. What am I going to get? I'm going to get a negative number. So that's telling me that my position, well, we said velocity, that means he's going up, and then he's going down, right? So he's going up. Babe is going up on 0 to 15.5 and down on 15.5 comma infinity. Okay, so the bottom of the hill, I understand he's going to keep going down. For simplicity's sake, we're saying, according to these equations, he keeps going down forever. Yes, there is a point when he hits the ground, but this is more just for us to understand how to use these equations and evaluate things. So don't think about this too realistically. That really accomplishes everything I wanted to accomplish. So how far up the hill does Bobby go? Let's see. So we need to figure out how high he rolls up before he stops. So, oh, we know he stops at 15.5. So if I plug in 15.5 to my position equation, which I'm not even going to pretend to do without a calculator, which, like, to be fair, I could totally do this without a calculator, but why am I going to? 385.25. So that's how far he rolls up. And no, we don't have units, so we don't need to include units. And then D, how fast is Bobby rolling when he gets to the bottom of the hill? So just realized I didn't include anything about the bottom of the hill. So, since I didn't include any information about that, oh wait, no, is it just that, like, does position just need to equal 0? I feel silly. It wasn't all that. I was overthinking it. We just want to know when his height is 0. He starts at 145 off the ground. We want to know when he hits 0 off the ground. So I'll just set 0 equal to 145 plus 31t minus t squared. And we'll be able to find out what time he is when he hits the ground. So even though he's not like going straight up and down, this is still working. So I'm going to just assume that I am not going to solve this by hand easily, and I'm just going to graph it and try to find out when he hits the ground. And my calculator died, that's cool. Cool, bear back. All right. I was just going to have that be the end of the video, and then I realized, I was like, oh shoot, there's more work. I actually have to, like, I feel so silly now. Just now, not ever before. All right, so I don't see where it's touching, so I'll zoom fit. Sometimes that helps. Oh, he goes a ways out. Oh wait, we know that at 15.5 seconds he's still up there. So let's go out to like, let's go out to 35 seconds. He should hit by then. Barely. I'll go out to 40 seconds. And I don't need any negative y values. So I'm trying to find out when he hits 0. So left bound, okay, there's my left bound. Now right bound, and I got that it equals 0 at, so t is equal to 35.128. And then I'm supposed to find the speed when he hits the ground, so the velocity of 35.128. Let's find out what that is. It's going to be 31 minus 2 times 35.128. So that's 31 minus 2 times 35.128. And I got negative 39.256. But speed is absolute value of that, so 39.256. All right, so sorry about the getting off track there. If you couldn't tell by the yawning, I'm a little tired, but hopefully this was coherent and helpful. I love you guys lots, and I'll see you tomorrow. Bye!